All right, so 2.6 is what I'm going to do next, limits at infinity. So we're basically going back to limits, but this time we're going to do limits at infinity. What happens when we send x to infinity? What's the y value, okay? To do so, I'm going to start with an example. Let f of x equals 2x plus 1 over x minus 1, and we're going to do a t-chart, and we're going to send x to infinity and see what happens. So we're going to say x equals 10, 1,000, 100,000, actually a million. So you can see I'm increasing x without bound, and then 10 million. And then negative 1,000, negative a million, and then negative 10 millions. So if you punch this in your calculators, you're going to see this is 2, 2, 1.997, 2.333, 2.003, 2, 2. So it shows me as x goes to infinity, positive infinity of 2x plus 1 over x minus 1, we get 2. And as x goes to negative infinity of 2x plus 1 over x minus 1, which is also 2. So this is just an example. So the definition for limit at infinity, let f be defined on the interval from a to infinity. Then the limit and as x goes to infinity of f of x equals L means, as you saw, that f of x, the values of f of x increases the value of f of x can be made arbitrarily close to L when x increases without large. So we saw in the example, the limit of f of x as x goes to infinity equals L means the values of f of x can be made arbitrarily close to 2 when x increases without large. Same with negative infinity. If f is defined on negative infinity to a, then the limit as x goes to negative infinity f of x equals L. It means f of x can be made arbitrarily close to L when x decreases without large. Okay, decreases without large. And now comes the horizontal asymptote definition. Horizontal asymptote. The line y equals L is a horizontal asymptote. Okay, HA is horizontal asymptote to the graph of f, if the limit as x goes to infinity f of x equals L, or limit as x goes to negative infinity f of x equals L, or both. It doesn't have to be both. So the example we just did, we saw the limit as x goes to negative infinity equal 2, and as x goes to infinity equals 2. Let's see the grapher, what that means graphically speaking. So y equals 2x plus 1 divided by x minus 1. You can see as x goes to negative infinity or to positive infinity, y equals 2. And if we draw the line y equals 2, you can see how horizontal asymptote act. So the line goes along that horizontal asymptote as x goes to negative infinity or to positive infinity, okay? All right. So theorem 5, if r is greater than 0, is a rational number. So r is a rational number, no square root. Then the limit as x goes to infinity of 1 over x to the r equals 0. Why is that? Because say r is, as long as it's rational number and it's positive, like if it's 1/2 or 3/2 or 2 or 10 millions, you're doing infinity. So basically you're doing 1 over infinity to a power, a positive power. And that's 1 over infinity. And a number divided by infinity is always 0. Whether it's 1 or 2 or 3 or 10 or -5, it's always going to be 0. So a number divided by infinity is 0, number other than 0, okay? And the limit as x goes to negative infinity of 1 over x to the r equals 0. As long as x to the r is defined and a real number. Let me see, I think I made a mistake here. Okay. So the second one, if you have negative infinity and then you move it up, that's not going to be right. That's not right. So what they mean, I think, by this one, if it's x to the negative so you have negative infinity, you move it up, it doesn't. Let's wait on this one, okay? Let's wait on this one. So for example, what is the limit as x goes to infinity of 1 over x to the 3/2? Well, this is like 1 over infinity, which is 0. What's the limit as x goes to negative infinity of 1 over x to the 2/3? Well, as long as it's defined, well, when you do a cube root of a negative, it's negative, and then you square it, so you get infinity. So this rule is true, okay? Okay. When you have a negative infinity here for x, then you can do cube root as long as it's defined. That's why. Okay, so this is good as long as x to the r is defined. All right, so now we have a shortcut rule to find the limit as x goes to plus or minus infinity of f of x over g of x. We can do this in two ways. We can find the limit of the leading term of f divided by the leading term of g. Why the leading term? Because when you have x to the 4 plus x cubed plus x minus 1, and if x is infinity, it's like having Bill Gates, because infinity to the 4th power is huge, and then everybody else. It doesn't really matter if you're talking billions versus 1,000 or 1,000,000. So So this is going to be the dominant. When x is infinity, you can ignore the dollars and only focus on the billions. That's what this is all about. As long as x is infinity, you can do that. Okay? So for example, if you want to find the limit as x goes to infinity, again, this rule is only true when x is infinity or negative infinity. 1 minus x squared over x cubed minus x plus 1. You can ignore the 1, so you'll just do negative x squared, and you can ignore everything else, just x cubed. You can reduce it, so it's negative 1 over x, and negative 1 over infinity is 0. Okay, so makes life easier. Or you could divide it. There's another method, or you could divide everything by the highest power. And the highest power in this case, I mean, this is more work, but I think it makes sense. The highest power here is x cubed, so you divide every term by x cubed. So this would be 1 over x cubed minus 1 over x, and then 1 minus 1 over x plus 1 over x cubed. As x goes to infinity, 1 over infinity is 0, minus 0 over 1 minus 0 plus 0. So 0 over 1 is 0. You pick which method you want to use, okay? Another example, the limit as t goes to infinity of t minus t root t over 2t to the 3 halves plus 3t minus 5. This is the same thing as t to the 3 halves, t times t to the 1 half. So the highest power is t to the 3 halves. So this is, if you want to use the shortcut rule, you can ignore the t, just leave the negative t to the 3 halves, and then 3 half, and everything else is cancelled out. Again, because t is infinity, we can do that. That cancels out. So the limit as t goes to negative infinity of negative 1 half, it's a constant, so the constant doesn't change. Number 26, page 138. What's the limit as x goes to negative infinity? Square root of 1 plus 4x to the 6 over 2 minus x cubed. Well, you can ignore the 1 there, so you get square root of 4x to the 6. You can ignore the 2, so you get negative x cubed. So this would be negative 2x cubed over negative x cubed, because x is negative. So when we do square root of x to the 6 and x is negative, it's going to be negative x cubed, okay? Because when you do square root, you cannot get a negative answer. If you do x cubed, that's negative. Why negative? Because x is negative. Remember, square root of u is the opposite of u if u is negative. That's what this is about. So this would be negative 2 over negative 1, which is 2. Now, if you look at 30, page 138, limit as x goes to negative infinity, square root of 4x squared plus 3x plus 2x. Okay, so if you ignore the 3x and x is negative, square root of 4x squared is negative 2x, and if you do negative infinity times negative 2 is infinity, and then 2 times negative infinity is negative infinity. So we don't know which infinity is bigger. That's not 0, because this could be 10 trillions, this could be a million, okay? So always when you have infinity minus infinity, it's indeterminate. But infinity plus infinity, Bill Gates plus Warren Buffett is infinity. It's more. Negative infinity minus infinity is negative infinity. But negative infinity plus infinity is indeterminate. Keep that in mind. Okay. So if you do that, then we don't know what to do. So since it's a square root, we're going to rationalize. So how do we rationalize it? We times by the conjugate, and the conjugate is 4x squared plus 3x minus 2x, and divide by the same, square root of 4x squared plus 3x minus 2x. And then we're going to do the limit as x goes to negative infinity. So if you FOIL the top, it will be 4x squared plus 3x minus 4x squared, which will cancel out. So you get 3x over square root of 4x squared plus 3x minus 2x. Now, if you do the limit again, 3x is 3x, you can't change that. And it will be square rooting, so you can ignore the 3x. It would be square rooting 4x squared, which is negative 2x, minus 2x. So this would be 3x over negative 4x. The limit as x goes to negative infinity, which is 3 over negative 4. Negative 3 over 4. Alright. That was a little tough, but we need to practice that. 36, page 138. You have the limit as x goes to infinity of sine square x over x squared plus 1. The problem with sine x, when x goes to infinity, sine alternates between negative 1 and 1. We cannot just say it's a specific value. So for that matter, we need to use, we know that the sine x is between negative 1 and 1. And we need to use the sandwich theorem that we did previously. So if you square, so if sine x between negative 1 and 1, then sine square x is going to be between 0 and 1. Okay? And if you divide by x squared plus 1, which is positive, as x goes to infinity, this goes to 0. And as x goes to infinity, 1 over infinity is 0, so this must go to 0. Okay, so the answer is 0. Okay, a couple more theorems. So limit as x goes to infinity of e to the negative x is 0. Why is that? Because e to the negative infinity is 1 over e to the infinity. E is bigger than 1. To infinity is infinity. 1 over infinity is 0. That's why. Same thing with x goes to negative infinity of e to the x. This would be e to the negative x, which is 1 over e to the x, which is also 0. 1 over e to the infinity is 0. e to the negative infinity, 1 over e to the infinity, which is 0. Alright, 34, page 138. What's the limit as x goes to infinity, e to the negative x plus 2 cosine 3x? So if we do e to the negative x, e to the negative infinity is 0, plus this does not exist, because as x goes to infinity, cosine, again, could be anything. It alternates between negative 1 and 1, so this does not exist. If part of it doesn't exist, then the whole thing doesn't exist. Okay, number 44. F of x equals 2 over x minus 1 over ln of x. Part A, what's the limit as x goes to infinity of f of x? Well, 2 over infinity is 0. Ln of infinity is infinity. So 0 minus 0 is 0. Again, if you don't see why, ln is, this is the function ln. As x goes to infinity, so does y. Part B, what's the limit as x goes to 0 from the right of f of x? Well, 2 over 0 is infinity, minus ln of 0 is negative infinity. Infinity plus infinity is infinity. And part C, limit as x goes to 1 from the left of f of x. So 2 over 1 minus 1 over ln of 1. 2 minus 1 over 0, ln of 1 is 0. 2 minus infinity, which is negative infinity. This is minus negative infinity, so it's plus infinity, because as x approaches 1 on log, this is 1. As x approaches 1 from the left, y is 0 minus. Okay? And that's why it's going to be plus infinity. Alright, you can do the rest. One more, number 50. Page 138. Y equals 1 plus x to the 4. Sorry. Okay, so number 50, page 138, y equals 1 plus x to the 4 over x squared minus x to the 4. We need to find the horizontal and vertical asymptotes. You may want to use a graphing calculator to check your work. Okay, so to find the vertical asymptote, we set the denominator equals 0 after reducing the fraction. This cannot be reduced. X squared minus x4 equals 0. 1 minus x squared equals 0. So x equals 0 plus or minus 1. Okay, you have 3 vertical. To find horizontal asymptote, remember we just did horizontal asymptote. Limit as x goes to infinity of 1 plus x4. We ignore everything except the highest power, x4 over negative x4, which is negative 1. So again, to find the vertical asymptote, we usually do the limit as x goes to 0. And to find the vertical, or if it's a fraction, we reduce and then we do the limit. We reduce and then we set it equals 0. To find the horizontal asymptote, we do the limit as x goes to infinity. Whatever value you get is your horizontal asymptote. And that's it for 2.6.